Alright, so this is going to be my video on the updated collision system. Let's start with the diagram. So here we have, let's go over the volume. We have our base collision volume. It keeps track of the every collision volume's default center and radius out here, and that data, it has the compute data, the double dispatch, and visitor pattern, the update for the default bsphere, and some default accessors, as well as the debug view. The collision bsphere goes in, or it gets its information from just the base collision volume. Down here we have the default bounding box, which allows for cross collision computations between the AABB and the OBB. So here in the bounding box, we keep track of the common OBB, or the common bounding box collision data, so the half diagonal, the max, the min, the scale squared, and the center of the box, which is different than the default center. And then over here we have the more specialized functions and all the collision things. So the the double dispatch and visitor pattern. In here in both of these, because these are the derived types, those functions live here, and then the rest of the functions, and then I have this prepare OBB data so that the ABB is not calculating all of the OBB stuff every frame. So that's that. These are just the command structure I have. I have a collision command based. The three lovely collision test commands that I will go into a little bit. The compute ABB and the collidable group delete command. This is a new one to help with tiered collision, and the group delete command. Just for the collidable group has an AABB as well as a collection, and some accessors and stuff like that, and it's singleton. And then the collidables don't have a graphics object, they have the collidable model and the volume. These two, collision and collision terrain, are callback functions for collision either with another object or with the terrain, accessors, and the update. And then this is the enum for volume type. Here in my little test environment, I have, I believe it's AABB collision. I'm just going to demonstrate that the tiered stuff works before I jump into it. I haven't changed anything, so it shouldn't take this long to build. It's uncomfortable. I'll start pulling up collision stuff. There we go. Okay. Also, GodCam works. I had it last class, but still GodCam, and that's a bsphere. And this is all in DX, if that wasn't clear. Everything that I show you today will be in DX. I will not be in OpenGL at all. So here we have the group AABBs. There's only one of each, so they're pretty small. As the two AABBs collide, we have the axis default bounding sphere and the frigate default bounding sphere. As the two bounding spheres collide, we have now sorry, I'm a fool. So we have an OOBB on the frigate right here, and then we have what looks like an AABB. It might be an OOBB, but it's one of the two. And then as these two get closer, boom, they turn red. Oh, I hate that you can't see anything inside. It's made, we're not here to talk about that, but that's something I wish I could fix. So yeah, tier collision works. One of the issues I had with, I'll address this later. That's not for this video. So the issue I had when I first did the tiered collision, is that I was computing the group AABBs more than once per frame. I have fixed that, so now what I have is a compute AABB command. So I believe it's in our collision manager, which is objects, managers, collision manager. Let's see. So we have two stages to our process collision tests. We have process computations and process tests. Process tests is exactly what process collision tests was back in 374. We're just executing all of our collision tests. Computations, though, we're going through and we're calculating all of these compute AABB commands, which are just computing all of the group AABBs, storing them in the collidable groups, computing them once per frame, and then doing our collision tests with that updated info. And those are spawned in the same way as the collidable group delete commands. When a collidable group is created, it creates its own delete command and its own its own computation command. And if I wanted to go into some sort of bounding volume hierarchy system or an octree type system for collision, and I had to do once a frame computations like that, I've left this pretty generic, just the process computations. So more computations could happen there than just the AABB. That's interesting. That's something I will hopefully get to doing over the summer because I really want to do that. Credibles, saw that. Internal base volume, yes. No graphics objects. That. Class diagram. Update intersection using visitor. Looked at that. Yes. Groups AABB and the accessor for that, in case it wasn't clear. It's right. Would be in the collidable group, which is over here. Get collidable collection. It's right there. There's the accessor. That is not the right one. That's Facebook. Compared to update, yes. Once per frame only. Train collision group updates. Yes, I believe so. Tiered approach, we saw it. Oh, for the self test pair, we had the 4 steps. It's groups collide, collidable and collection 1. Groups collide, B-sphere collides with. Whoa, restart. 2 groups collide. Collidable's B-sphere collides with collection 2's AABB. B-sphere collides with B-sphere, collision volumes. That's the test pair. Test self is test B-sphere, test volume. It's great. I will do the test command, the terrain, later in the terrain video. And I believe that is it. Let's just go into the visualize while we're here. Render request done through the command. I'll end this video here because I haven't prepared this.